We're going through some pretty interesting times right now. I don't know whether you feel up to the job or not. If not, you're certainly not the first person to feel that way. Remember when the Lord told Moses at the burning bush to go down to Egypt and lead the people out, Moses had all kinds of reasons why he wasn't the right person for the job. And the Lord didn't really disagree with that. He just said, go anyway, because I'm with you. So the Lord does not call the qualified, he qualifies the called. You might think about the fact that God's not asking you to do what he is because you're capable of it, but because you're willing to do it in him. This lesson is not in the text, but it is from notes section time series 1 posted on Brightspace and an Excel spreadsheet section 4.0 CM1. And there'll be a short follow-up to this lesson later. The notes look like this, and let's look at an example before we talk about what we're trying to do here. So if you go shopping for a loan to buy a house, usually you have a choice of a fixed rate mortgage or an adjustable rate mortgage. A fixed rate mortgage is just that. The interest rate is going to be 4% for however long you have the loan or whatever the rate is. But an adjustable rate mortgage follows the economy. So the rate next year, your interest rate next year may be higher or lower than your interest rate this year. And those adjustable rate mortgages are usually pegged to some measure of interest rates. So, for example, the US Treasury Constant Maturity Index tracks a number of economic data, and then banks peg their own borrowing um, to measures like this. The data looks like this. It's just 3 years or so worth of data each month. And if we were to graph the data over that 3-year period, it looks like this. So you see a general trend upward with a lot of seesawing along the way. So I ran linear regression and got this model as a prediction of the CM1 over time, or as a function of time n, and then ask Excel to generate the residuals, and here they are. So you see an obvious trend in the residuals. There's some seesawing up and down, and from our earlier work with models like this, we might think, okay, now it's time to tackle this with some sinusoid model or something like that. But think about where this data comes from. This is financial data, and it's data that's being basically set by policy of the Federal Reserve, the US central bank. And the Federal Reserve has no intention of following seasonal trends. They are trying to smooth out the overall economy. Furthermore, if you look at the kind of the period of the ups and downs, or I shouldn't call it a period, but the distance between ups and downs and so on, it doesn't seem to have a fixed period, nor really should it, for the reason that I just said. This is not happening because of something that like Christmas that happens once a year or anything like that. It's bank policy. So I would say here, no, rates follow policy set by the Federal Reserve. So even if there does seem to be some sort of cyclical pattern here, it's probably accidental and not a good idea to try and use a sine wave, for example, to model it. Let's lay that aside for the moment and tackle another issue. Is very short-term forecasting of financial indices useful? For example, would it be useful for us to be able to predict the price of Apple's stock just tomorrow, say? Well, sure. today is today. If I knew that the price of Apple stock was going to be higher tomorrow than it is today, I'd buy some today. Or if I knew that it was going to be lower tomorrow, I'd sell some if I owned any. So yes, even one day forecasting can be profitable. So this is context dependent, right? If I'm studying climate change, for example, to be able to predict the temperature next week or tomorrow is probably not very interesting. I'm interested in long-term trends over decades or centuries. But if it's a financial product, having a one-day forecast could be extremely useful. And furthermore, what's the best predictor you can think of for the price of Apple's stock tomorrow? We might think of all kinds of things that could happen, but let me suggest the following. Best predictor of Apple's stock tomorrow is Apple's price today, which we know. I can go online and find out what the price of Apple's stock is today. And if I can somehow crank that into a forecast for the stock price tomorrow, I'm in business. So putting all of this, what we've been discussing together, a new form of model is suggested that the price of stock next time period can be predicted using, see, this is a plus B1, predicted using this month, the month number, and then the stock price right now. So next stock price is predicted using both the time involved in and the current day's stock. Okay, so couldn't have said it better myself. So now let's do that. If I go to this data, what I need to do is have two predictors, the month and the previous day's price. So here's a way we can set that up on Excel. I'll insert a column here and call it, say, lag 1. These are going to be the stock prices lagged by 1 day. And so I can manually build that by just selecting the CM1 data and copying it back into column B, but dropped down by 1 month, like this. And so now the idea is that I would use month number 2 and this delayed version of the stock price to predict the next stock price. It's fine to use 6.73 to try to predict 6.27 because 6.73 has already happened and is known. And so now we're ready to run regression from data analysis and clear out some old things here. For our Y range, our dependent variable, it can be these values. Okay, I have to be careful right here. When I run regression, the dependent and independent variables have to be defined for exactly the same time periods. And since for month 1, I have no lag 1 predictor to use, I shouldn't use month 1 data at all. For the X range, come here and select both columns A and B, but again, only for rows for which all 3 columns are filled, like this. Be careful with this box. I'm not highlighting the labels now, so don't check that. And since this gives us a lot of output, let's put it in a new tab and let's check residual plots so that we can see what's happening. So Excel works and gives us this. Here are the coefficients of the model down in this area. And we asked for residual plots, so it gave them to us. There were 2 independent variables, remember, and if I look at the time scale, this one is the one that I'm most interested in. This is the residuals plotted as a function of month number. The other one is actually the residuals plotted as lag one, which might be interesting for another purpose, but for us, this is the one that we are interested in. Back to the worksheet. So here are the residuals from lag one. And same question, and here's the model, by the way, and then same question, are there still trends in the residuals? And the answer is much less than before. Before there were clear patterns in the residuals. Now, much less, but there probably still are some. There are a bunch of residuals that are down below, then it jumps up for a while, then down below, then up for a while, and so on. So less obvious than before. But still, yes. And so we wonder what to do. Well, now that we have this game going, the thought comes to mind that maybe instead of just using the previous month to predict this month, we could use the previous 2 months to predict this month. After all, the price of Apple stock this month isn't only related to the price last month, but also to the price 2 months ago, and so on. So then that suggests that we do the following. If I go back to my data, I can insert another column and call this, say, lag 2. And that can be just the CM data again. And let's see, it can be, don't want to do that. The CM data again. Copied, but shifted down by 2 units. And then try to use month, lag 1, and lag 2 to predict the CM1. I won't do that, it's just done in the same way. And we get a regression model that looks like this. Are there now trends in the model? Perhaps very slightly, but hardly noticeable, certainly again less than before. So this time I'm going to say very little, if any. And so when we see random residual patterns like this, this tells us that we've probably tweaked most of the information out of the data that we're going to be able to, and this might then be about as good of a model as we can do. So then if I could go back to the spreadsheet, there's actually a tab completed, which I'll go to now. What I have done at this point is to take the coefficients that our lag2 regression just found, and then generate a column of predictions. So in our notation on the worksheet, this is B0 plus B1 times N plus C1 times lag1 plus C2 times lag2. It generates this column of predictions. Notice again that I can only generate predictions in rows where I have all 4 columns of data. So I generated the predictions and then put things on a graph. And here it is. In the blue are the original data items, and in the red are my lag2 predictions. Notice that overall it's an excellent predictor. The R-squared turns out to be like 0.94, I believe. But in terms of getting rich by predicting Apple's stock price, notice that you're not going to be able to do that. Because, for example, here comes CM1 right here, and it's going up. then in the next stage, it goes back down again. So the right place to sell Apple stock would be, say, right here, just before it starts going down. But because these are lagged, the model doesn't start going down until the day after. And so you're always like one day too late before to be able to react to sudden changes in the stock market, which is what needs to happen if you're going to get rich on short-term trading like that. But if I'm interested in a more stable overall financial model, this looks like a pretty good prediction of CM1. And so how could I use this model? If I wanted to know, for example, a prediction for CM1 in month 39, which is 2 months past what I have data for, then I could do the following. I have to run this model 1 month at a time because that's how it's built. So my prediction for CM1 in month 38 would be to take these this model and plug in n equals 38. So 1.785 plus 0.0330 times 38, then plus 1.104 times x 37 rather, and minus 0.435 times x 36. Now, these are known values. X 37, if I look at my data sheet, is 8.44, and x 36 was 8.98. So I can crank out that number and get 8.45, and then I just run it again. What's my prediction for the CM1 in month 39? 1.785 plus 0.0330 times 39 plus 1.104 x 38. Well, okay, I don't have x 38. I have 37 months worth of data. So what's the sensible thing to do? Use my previous month's forecast instead, and minus 0.435 times x 37. So though we don't know the actual value in month 38, we predicted it to be 8.45, and the value in 37 we do know is 8.44, and so this cranks out the number 8.73. So I have a model that's capable of generating pretty accurate forecasts. The price to pay is that I can only generate forecasts a short distance into the future. You can see that when you start running this multiple time stages into the future, you keep using forecasts based on forecasts based on forecasts, and the error tends to accumulate as you try to project farther and farther into the future. We'll stop there.